Okay, so today in notes, we are still looking at linear, quadratic, and exponential, but we're going to take this a lot further. Okay. Okay, so first thing we want to make sure that we are okay with, which we've been talking about, we just haven't sort of formally written it down. For something to be a linear function, okay, we are talking about functions in all of these situations. Okay, which means a function can be represented as a table, a graph, ordered pairs, right? A mapping. We can talk about its domain and range. We could represent that in a word problem. We could translate that word problem and talk about key components of it. And I see your faces going, oh geez, this is a lot of info from way back when. And that's why I said this is difficult. Okay, but everything with a linear function is always based on the fact that we have a constant rate. Anybody know, sort of mathematically speaking, is a math term? What sort of math value tells us that there is a constant rate? What does a constant rate look like if we're looking at a graph? Maybe I should ask
Just
that.
like straight line.
Okay, it's a line. It doesn't have to be horizontal. It could be going like this. And what do lines have? A slope, right? This slope tells us that it's always up a certain amount and over a certain amount every single stinking time. Okay? That's what makes it linear, a constant rate. So let's talk about, you just told me, so there's one of the pieces actually, you just told me, a linear graph is a line. Right? It doesn't have to be horizontal or vertical. It just can't be a circle. What do linear equations look like? What do linear equations look like? Oh, they have an equal sign. That's a really good statement, right? Equations always have equal signs, so we know there's got to be an equal sign in there.
Numbers.
We know there has to be a slope in there. So what type of equations have a slope, have an equal sign, and have numbers? Y equals mx plus b is one of our beloved ones. Now, we said there were other ways to write linear equations, right? Point slope form, standard form. But the key always came back to that the equation had a degree of 1. Holy cow, that's our polynomials unit. What does a degree of 1 mean? Just x, right? So far we've talked about slope, we've talked about our rate of change when we were graphing, right? We've talked about our equations, y equals mx plus b, point slope form, standard form, and now we're pulling from our polynomial unit. Right? I told you this was sort of putting our entire year together into one big, nice, neat circle. Here's everyone's favorite category of linear equations.
Sarcasm.
Yes, that was a bit of sarcasm there. What do linear word problems or story problems look like?
They give us the information. Wow. They give us a formula, or they give us a formula and the numbers to plug into it.
Not necessarily. It could.
They give us the numbers and the problems.
Okay, you guys are being way too specific about what type. So let's think about all the different type of linear word and story problems we've talked about. We talked about perimeter. Okay, we talked about distance equals rate times time. We talked about breaking even. We talked about total. We talked about being able to set up proportions. Right? Those don't all fit one specific category, but they all do have something in common.
Numbers.
They do have an equal sign. They what?
Too many words.
Quadratic.
Can we have a hint?
A quadratic formula wouldn't fall under linear. Yes, you can have a hint. It has something to do with what we put up there for our definition of linear.
Oh, it has a rate.
Right? These all have some type of constant rate in them. For example, could I say, I'm trying to make a decision of if I want to go with Sprint or Verizon. Okay, Sprint is going to charge me an extra $2 one month, an extra $17 another month, $24 one month. Then I'm going to save some money the next month. Is that linear?
No.
Why not?
Because it's not constant.
It's not a constant rate. They all fall back on this idea that, right, if the proportion of the building shadow to a tree shadow has to be a constant comparison. Okay, so we have something in the story problem that's telling us there is some type of constant relationship happening. Now, obviously that's not quite as specific as, oh, well, it's really easy to tell from a line, because a line just is a line. Right? A word problem, we're going to have to do a little bit more reading and make a decision from there. Okay, but can we at least be okay with all of that making up constant, or all of those making up linear function parts? Are we okay there? Okay. We have quadratic functions. Right, again, these are all functions, which means quadratics can be represented as a table, a graph, a mapping. We could talk about its domain and range. We could list its ordered pairs, right? We could have a story problem. We could talk about its max height. Those are all things we've done. Okay, for a quadratic, I don't know if there's a nice, neat word here to put up at the top. So let's start breaking down into our categories. Blue. It's just water. It falls from the sky.
Yeah.
A quadratic graph. What does a quadratic graph look like? A parabola. What does a parabola look like? A U, right? So it's a U shape that we call a parabola. Okay, that one was red. What does the quadratic equation look like?
X squared.
XT.
Yep, it has an x squared in it because it's quadratic, right? It has a degree of 2.
Negative b.
Okay, so it has an x squared in it. What types of ways can we write quadratic equations that we know of?
Factoring.
We can factor to solve,
Solve.
but what were the two forms we talked about them looking like to be able to graph with?
Y equals to y negative b.
Y equals negative b plus or minus.
No, you're talking about ways to solve right now. What y equals mx plus b is something that looks like a linear.
No, it's a
What's an equation that looks like a quadratic?
y equals b over 2.
B over 2.
Oh, yes.
bx plus c.
Oh, yeah.
Right? Those were the looks that we had for equations. This activity is going to be really hard for some of us who aren't getting this info written down.
Oh, isn't the second one the thing we use for graphing?
Yeah, we use these both for graphing, right? To graph in this form, we did negative b over 2a. Right? That's how we find the vertex, but that's not just what the equation looks like.
I remember finding h and
H and k is in this one. What do quadratic word problems look like?
They give us the formula.
It gives us the form, it gives us that equation. Right? Because we've decided we don't actually really know how to write a quadratic. Because we don't know enough about velocity and gravity and some of those physics pieces. So it would give us the equation and then we would just have to use it. Okay? Yes, Olivia?
What's the definition of quadratic?
Yeah, we don't really have a nice word to go up here. Because quadratics are kind of weird. Right? We can't say that it's constant because maybe if anything, I would maybe say that this is symmetric. I'm not sure that's really fitting the exact same thing. Quadratics definitely kind of have their own little weird stuff going on, which is why when we talked about quadratics, right, I told you you don't really necessarily know all those pieces of the word problems and things like that. Let's see, our last one is exponential. Okay, so what do we say in the POD? An exponential doesn't have a constant rate. An exponential has a constant what? A constant.
Oh!
Yeah.
Right, it has a multiple that's common. So that's going to be like a 3%. Right? Something that we're multiplying by each time. This is a function. So again, a function can be represented as a graph, a table, ordered pairs. We could talk about a domain array, right? All the same things. So what does an exponential graph look like?
This one.
Oh,
yes.
The L.
Yeah, I don't have
A swoop.
a swoop.
A
Now,
swoop.
keep in mind, right, it could be doing any of those sort of directions. Just like a parabola can open up or down, we can have exponential growth, we can have exponential decay. What does an exponential equation look like? So a linear had an exponent of 1, a quadratic had an exponent of 2,
Exponent of x.
an exponent of x, right? It has an exponent of x. So that was any of our, like, these type things. What does an exponential word problem look like?
These ones already given.
Nope, we wrote the equations for exponential growth and decay, right? Y equals A times 1 plus or minus R all to the X. What have all of our exponential word problems look like?
X and then the left bracket, y minus.
Right, so we have that format of y equals A times 1 plus or minus R all to the X. Okay, what is R?
Rate.
And what is rate?
Percent.
A percent. So what have all of our exponential story problems have? A percent, because a percent is a common factor, not a constant thing that we're adding or subtracting. Right? So these have all had a percent because that's then a constant factor. Because you multiply with percents. Right? All like, oh, right? This is how they all go together. Yes, Olivia?
What did we say the word problem for linear looked like?
They all have a constant rate in them. Right? That slope, that constant increase. You have to look for it. Just like sometimes when we said half of the participants are eliminated, right? We didn't specifically see a percent, but we knew that half being eliminated was 50%. So when we were talking about exponentials, we knew there was a percent in there, right? So we won't always just immediately see it. Sometimes we do, sometimes we don't. Okay, are we okay there? That's not all I need you to write down.